Force. Name of this lecture is force. Standard is over here is written 8th. Standard is 8th. My name is written over here. This is my name, it's me. And here name of this lecture is force, which is written over here. And here both person are pulling. I think yes, these two persons are pulling what rope. So it shows what we are going to discuss, what force, pull or push. This is what we are going to explore in details. We will have more information at the end of this lecture. So let's begin. So from this slide, what did you understand? You understood that standard is it. This is my name and it's me. Name of this lecture is the force. Both persons are pushing this rope. It shows about topics that we are going to discuss in this. Now let's start with the introduction to force. Here we have a figure. With this figure we will visualize. Okay, here force is a push or pull acting on an object. Force is just to define force, you can say it is just push or pull, that's it. It is just push or pull, that's it. Here this is object, clear? This is object. Now I want to push it, then of course I will apply like this force. So here I am pushing this object. I can pull like this object. I can push this object. So it shows that we are applying force. Pushing, pulling is just force, okay? Clear? Force is a push or pull acting on object. So this we considered it as object. Name of this object would be something. We know that this is object. Okay. Object will move when we will push or pull. When we will apply force, then object will move. Object will change its position, its self position after applying force. This is what will happen. Clear? Here next, it can change the state of motion. Okay, yes, of course. This object is in rest. I am going to apply force. Now, what happened? It came into motion. Now, it is in rest. So we can change state of object. We can change state of motion of object. If this any object which is in rest can come into motion after applying force, it can be pushing, it can be pulling. Clear? If there is an object which is moving, now if we apply force, then what will happen? Either we can stop the object, moving object, or we can accelerate the moving object. Yes, these two things can happen. One thing more, we can decrease the speed of moving object, or we can increase the moving object, speed of a moving object. This is what can happen when we will apply force. So here we are changing a speed of a moving object. We can change a speed of a moving object. We can stop to moving object. We can change state of a object into motion. Clear? This is what this is what will happen when we will apply force. Here one more, it can change the shape of an object. Shape. This is object. Let's consider it again. This is object. I gave you it. Okay, I gave you it. I am and I say that change shape of this object. Will you be able to change shape of this object? Of course no, because it is a solid. It is a rigid solid material. That's why you should, to change the shape of an object, you should have flexible shape or flexible object. Then you can change shape of that object. Okay. So you should have what, rather than having a rigid solid object, you should have a flexible solid object. Then you can change shape of object. Now this was a rigid solid shape. I am applying force. It is not changing its shape when when I am applying force. It is still as it. But what if I take another object, this paper, I am going to apply force. Here you can see shape of this is right now is like this. I am applying force. Now you can see shape of this paper became something else. So this happened because of we applied force. And here I said you should have a flexible solid shape. Then you will be able to. It is not liquid material. It is not a fluid material. It is a solid, but which type of solid? Flexible. It is rigid, hard. Flexible, which means soft. Rigid, which means hard. Clear, hard. This marker is also rigid solid shape. This paper alone, it is what? This paper alone, it is what? It is in plane shape. But now I am going to apply force. Here you can see it is changing itself when we applied force on this object. Here you can see length of this object was more, but now length of this object is less, as well as this length. I am talking about this length. We are able to change the shape of this object because of it is a flexible object. That's why. Okay. Now this slide is clear, but let me explain this figure. This woman is pushing this cart, isn't it? So it is also force because she is pushing the cart. He is pulling the wood. I don't know name of that wood. So he is pulling. She is pushing. He is pulling. Now he has a magnet. He has magnet. That's why this type of force is called magnetism force. Here person is sitting under the tree and apple is falling. This type of force is considered something else, and I can name that. I can take name of that force. Name of this force. It is a gravitation force because it is falling something from upward. That's why anything is falling from upward to downward is a gravitation force. Here he has a magnet, and work of magnet is to attract or repel. Okay. and here this child is coming from here, and the contact of this children, this cycle is with this contact, that's why this object will apply force opposite direction to block this object. This type of force will be considered as a friction force. And here it is also it is acceleration, which means speed is increasing or decreasing. Effects of force, we have seen effects of force: start or stop motion. If something is if object is in motion, if object is in rest, then we can take that object into motion by applying just force, by pushing or pulling. Anything can be brought into motion if initially that object is in rest. Now we can stop a moving object just by applying force. It happens in a reality. Really, it happens. It is happening. It will be happening. We can accelerate the moving object. It means we can increase the speed of a moving object. If a object is moving with a constant speed, then we can accelerate a speed of that moving object. Even we can decelerate, which means decreasing the speed of moving object. We can decrease the speed of moving object just by applying force. Change direction, yes, it can also happen. Look, a vehicle is going into a straight direction. Okay, a driver is driving vehicle. Okay, now there is a long straight road where driver will be moving. Driver is not moving just by applying a device. He is going in straight direction, but after 5 km there is a turn, and driver will take a turn, because just assume that after 5 km there is a turn. Now what will driver do? Of course, driver will apply a device to turn into another direction. Here he will be applying a device, so it is a device will be external force. Here that person is applying force by using just a device of the vehicle. So that is how a vehicle can change direction of a vehicle just by using device. It just not will happen with this vehicle. It can happen with any object. Even I am going in a straight direction. I am not riding any vehicle. Okay, I am going to my college, but there are there are 3 turns that we need to take turn. Then of course I will be going into a straight direction. Now turn came. What will I do? I will push my body to take turn into another direction physically. This is what will happen. So here I applied more force on me to take turn into another direction. So this is what is a force. It's an effect of a force. Force can change shape. Yes, we have seen. But here you should have a flexible solid shape, not a rigid. Nobody can change shape of a rigid solid object. Anybody can change what shape of flexible solid object just by applying force. Flexible, not rigid. So this is done. Effects of a force. Now let's move. What happened? Effects of a force. Accelerated. Okay. Types of a force. Contact force. We have types of a force. We are not talking about effects of a force. We are going to discuss about the types of a force. First is a contact and second is a non-contact. From this word you will be clear that contact, which means our contact would be with other object. Our contact with will be with other object. This is what meaning of a contact. But in this contact, what is the meaning of this word? Same, but something is similar. Contact forces. If there are two objects, let's take two objects just for example. Okay, we have two objects. We have two objects here. Again, this, not this. Then we have this. Are you able to see this? And this one is a marker, and the second is this object. Now I am going to apply force. So of course I am using this object just to push this object, second object. So here contact of this is with this object. Then this object will be able to push this another object. Are you understanding what is happening? When we will apply force by using this object, of course we will have to come in contact with this object. So here you can see what is happening. It came in contact with this another object. This type of force we consider it as a contact force. Friction is also contact force. Friction will happen when object will rub the other object. Object will rub the other object, then friction will happen. That type of force is considered as a friction force. Clear? Here we have two figures. This shoe and this is a ground level. You can assume that this is a ground and it is a shore. We walk in our daily life, and when we walk, then what happens? What happens? Then we can observe what friction force. This ground will apply opposite force. This ground will block this object not to go this object towards this side. Work of this ground level will be blocking this object, and this type of a force will be friction. Now here contact of this object is with this, isn't it? You can easily see it is touching, this shoe is touching this object, this ground. That's why there will be friction. Are you understanding? Okay. If you want to see muscular force or friction force, then of course both objects will be in contact with themselves. Here this person is pulling this rod. and it is possible because this person is in contact with this object. That's why it is possible to pull this rod. Okay. Now from this, our focus, we have to understand this, that contact of this is with this object will be contact force. Contact of this person is with this rod is contact force. That's it. Non-contact forces: gravitational force, magnetic force, electrostatic force. These are invisible force. You will not be able to realize directly. You will have to observe this type of a force, contact force. Non-contact force I am talking about. Okay. So non-contact forces are invisible. It is hard to observe directly this type of force. Now let's start from gravitational force. It is this gravitational force. Here, this is a gravitational force. Here, apple is falling. It is coming from upward, and it is falling downward. Anything which is coming from upward will be falling downward is a gravitational. It happened because of a gravitational. This type of a force is considered as a gravitational. That's it. That's it. Now next is here you can see, we cannot see that anybody applied any object applied force on this apple, then it fall down. We are not, cannot see directly. We cannot see directly. But here, wind, air, yes, this applied force on this apple, then this apple fall down. But I am telling you, you will have to observe if you wanted to see gravitational force. Clear? Now next. In the discussion of a gravitational force, you will also understand that the two objects attract to each other. Gravitational force is an attraction force. They attract to each other. Both objects will attract to each other. Here you can see this apple is attracting the earth, and the earth is attracting the apple. Both will be applying equal force. Both objects will be applying equal force. Clear? So here gravitational is attraction force. It is not a repulsion force. I am not talking about a magnetic force. No, here it is just attraction force. Work of two object is to attract. Then it is a gravitational force. I am not going in too much details about this gravitational force. This is enough for now. Next is a magnetic force. We should have a magnet. Right now I don't have a magnet. I can explain it to you very carefully. Work of magnet is to attract or repel. But remember, magnet will attract magnetic material. What is magnetic material? Magnetic material is a conductor material. Any material which can conduct electricity. But here, magnet. Sometimes you will realize that magnet is not attracting this copper. It is the other case. Okay, it is other case. Now I am talking about what? Magnet. Work of magnet is to attract or repel. If here you can see, if both sign of both ends of a magnet is same, then both magnet will repel to each other. If signs plus both are same, In the case of electrostatic force, this will happen same. In the case of magnetic force, this same will happen. Mm, but in the discussion of magnetic force, we don't take plus plus, we don't take minus minus, we don't take plus minus. It is not a standard taking a sign. In the discussion of a magnetic force, we take south pole, north pole. This is for magnetic. This is not. This is not for electrostatic. Remember, for magnetic force, we should take what south pole and north pole. These are two signs. Now, if one end of a object is south and in front of this is another force, another magnet, which this end, as here a sign is what is south pole. This both ends, south, both are in front of them. Then what will happen? Both will repel to each other because of their south is the same. That's why pole is the same. That's why to attract to each other, it should have this should have what this should be uh, unlike. This should be plus. If it is a plus, then it should be minus. If it is a minus, then it should be plus. If it is a minus, then it should be plus. If it is a plus, then it should be minus. Then now this both will attract to each other because of sign are unsame, unlike. That's why if signs are like, then both will repel to each other. Clear? This is enough for magnetic force. Now, what about electrostatic force? What about electrostatic force? Both one sentence, two sentence in this discussion will be similar, but little will be difference. Something will be difference for this definition, for this definition, for this definition. Little will be difference. In this we saw that gravitational force is a just attraction force. It is not a repulsion force. In this we saw magnet attracts the magnetic material. It repels also the magnetic material. But in electrostatic we will also see what repulsion and attraction. In the case of electrostatic force, we will have what electron ions, positive ions, negative ions, positive ions, negative ions. Now here in this figure, you can easily visualize that if ions, electrostatic charge, if electrons, I right now I will not say electron. If positive signs are same, then both will attract to each other. Both will repel to each other, not attract. If both signs are minus, then again both will repel to each other. If both signs are unlike, then both will attract to each other. So these are electric charge. These are electric charge. In the discussion of magnetic force, we were saying what sign of direction, south direction, north direction. But in the case of electrostatic, we have electric charges. Now let's take more knowledge about electrostatic force. Here we have static, which means electro charges are in rest. This is meaning of static. It is electric charges will be in rest, and here we can say these are in rest. But remember, both signs are same, then both will not be together. Both will not be together. Same, both signs are minus, again both will not be with together. If both signs are unlike, then both will be together. Both will be together. This is what will happen when two charges will meet in front of them. In front of them. Okay. Here you can see it is a gravitation. This is a gravitation. Here this is one object and this is a second object. Just to understand gravitational force, we will consider two objects. We will take two objects just for understanding gravitational force. One object will attract to another object and another object will attract to first object. Let's say this is the first object and this is the second object. This object will attract this object and this object will attract this object. This is what will happen, and this type of a force both are attracting. This type of force is considered as a gravitational force. Now here, how much newtons this object will be attracting this object? So I would say both. If this is applying 16 newtons, so this object will apply same 16 newton. Both will be applying how much? 16 16, same force. And here r is a distance, but here we will measure length from the center of this first object till the center of this second object. Clear? From here to till here, from here to till here, this is a distance. Clear? This is a distance. This f1 is a force. It is a push. It is a pulling this object, and this is a pulling this object. That's why we are saying this is f1, this is f2. Okay, and just to calculate the force, we will apply this formula. Z into, it is a constant, J into m1 into m1 into m2 upon r square. R is the distance, and here we will take r square because of this is a 2 times. This is a 2 times. This is a 2 times. Here r square, it is r square because of it is said that something is directly proportional to this. I don't know about that. I will tell you later. But right now, just understand that this is a formula to calculate force, and from this formula you can find distance if you have a given what force, value of a force. Then from this formula you can also find mass of one object, mass of another object. Okay. uh, this was about gravitational force, and this was about electrostatic force. This was about friction force. This was about muscular force. I am moving towards this slide. Here force can be applied into two ways. Either we will use a object, either we will be applying a force on an object just to uh, to to change the state of other object. So what is it saying? Force can be applied in two ways. By contact you can say. He is pushing this ball just by using his leg. So his leg will be touching this object. Then this object will come into motion. He will hit hardly here. Then eventually a speed of this more will be more, but at the final position a speed of this will be less, because he hit initially harder force, that's why here velocity will be more. So by contact we can apply, force can be applied by contact. From a distance, yes, from a distance it will be invisible, and it can happen only when yes, it happens in with gravitational force, it happens with a magnet. Here magnet is here, and irons are here, conductor materials are here, magnetic materials are here, but magnet is here. And this magnet will attract from a distance. It this object, this magnet, contact of this magnet is not with this, it is a, it is in front of this magnetic material. It is not contact, it is not in contact with this object. Clear? So here it will be, he will be, he will be touching this object, but this magnet will not be touching this object, but still this magnet will pull this magnetic material, and this type of force we consider it as a magnetic force. Now next we have pressure. It is also important to understand it. It cannot be ignored. It will be best for you if you understand it. Pressure, it will take area. Uh, in in the definition of thrust, thrust will not take area. Thrust will be upward force. Thrust will be upward force. Thrust is just a perpendicular force. A Okay, but here pressure will be perpendicular force, but it will take area. Here pressure is equal to force upon area, force upon area, like this, force and area. Here this is object, and force is a downward, force is a downward, and this is what, this is object. And we are talking about, we can also talk about area of this object as well as area of this object. Clear? More area, less pressure. This is main point for this discussion. From this you will be clear. More area, here you can see more area, less pressure. Here this area of this is how much? Area is it is directly proportional to this object. Here this is a more, this is more. Suppose pressure would be less area and more pressure. So here this figure is perfect for this. Here we can see here is a hand and book is over here. What is happening? Here pressure would be less because of it is on object which area is more, that's why here pressure would be less. So area is more, of course pressure would be less. If area is less, then pressure would be more, pressure would be more. Clear? This was about pressure. Formula of calculating pressure, it is just what, force upon area, force upon area. More area, less pressure, less area, more pressure. Clear? Thrust is just a perpendicular force, is a what, downward force. Pressure exerted by liquids and gases, by liquid and gases. Here liquids and gases exert pressure in all directions. Pressures increase with the depth. Used in dams, submarine design, sirens and water pumps. We have this beaker. In this beaker, there are three holes. In this beaker, there are three holes as you can see. Now here, height will matter. Height will matter for pressure. For pressure, remember. About it, I will discuss. It is beyond C. Here you can see this lower hole. It has more pressure. It has a more pressure. That's why it is here length of this is more. Length of this is more. And here pressure of this is less as compared to this, but pressure of this is more as compared to this. It is happening because of water is a falling. Water is a pushing downward force. That's why water is a pushing downward force. That's why it will have more pressure. Here water is here water is pushing force less. Here force of water here would be less, but here would be more. Here would be more. Clear? Height. Now let's understand. So as you can see, if this is the height more, then here height will be less. If here height is less, then here height would be more. This is what is happening. It is about beyond sea. It is a floating. It is a sinking. Let's see how can we say that it will float and it will not float. There is a reason behind it. If weight of this is less, if a weight of this is less, then this object will float, and mass of this is more than this object, this water, then this water, then it will sink. It will sink. Clear? And here you can see this object is applying downward force, and earth is applying upward force this object to this object to this object. Here same here, water is pushing this object, but this object is pushing this water. This object is pushing this water, and the water is pushing this object. This is what is happening, and both are applying same newtons. Number of newtons are same. Clear? Here this object is pushing this water, and water is pushing this object. Same here. But here, if density of this would be more, then it will sink. And here relative density, it would be more, it will be less, then it will float. But here it is sinking because of density of this is with the mass is more, and density of this is less with the mass. That's why it is a floating and it will be sinking. Atmospheric pressure. Atmospheric pressure. Air exerts pressure on everything, called atmospheric pressure, measured by barometer. Just how to measure atmospheric pressure? You can use a device which name is barometer. It decreases with the altitude. I don't know about it more. It is a device. Name of this is a barometer. Just by using this, we can measure atmospheric pressure. We can measure what is the pressure of atmospheric in the sky. Let's move. We have question answers. We have question answer. What is a force? Force is just push or pull. It can be also lifting, pushing, lifting, downward force, upward force, pulling, pushing. All these are force. All these are force. Name two effects of a force. Name two effects of a force. Force can change shape of an object if an object is flexible there. Just by applying force, a speed of moving object can be decreased, can be increased, can be decreased. We can stop a moving object. We can apply force on object which is in rest, and that object will come into motion. This is what will happen. This is the effect of a force. What is the formula for pressure? Pressure, just force, perpendicular force, and area of this area, and that is a perpendicular force. Downward force, this is upward force, this is a downward force. This is upward force, this is a downward force is a gravitational force, and upward force is a buoyancy. Upward force will be considered as buoyancy, and downward force will be considered as a gravitational force. Clear? What happens to atmospheric as altitude increase? It will decrease. I don't know answer of this. This is for you. The end. The end. Let's see what did we understand here. We saw introduction to force. We started from here. Then effects of a force. We understood types of force. In this, we understood about contact force, non-contact force. What are those waves? Uh, so force can be applied in two ways: just by contact, and with contact, and without contact. Without contact, force can be applied. This is what we saw. Pressure is just, it is a perpendicular force, and it takes a area. If the area of this is less, then pressure would be more. If the area of this object is more, then pressure would be less. This is what we saw in this slide. And here you can see in a beaker, water is full filled, and here there are three holes. But remember, as I told you, height will matter. If here this the height of this is less, then here height would be more. Here height is normal, then this will be normal. Here height of this is more, then here height this width would be less. This would be less. Clear? About buoyancy, we understood here. Buoyancy is a upward force, and downward force is a gravitational force. Work of buoyancy is to apply force downward, towards the downward. Here we understood what is atmospheric force. What device can be used just for measuring atmospheric? Then we answered that it will be barometer device. Barometer device. Next, we accepted some questions on this lecture. That's all about it. That's all about it. I think this is it.